Ethernet is an 802.3 IEEE standard. It's commonly used today, and in order to use it, a basic understanding of its fundamentals is required. So first we need to understand that the frame, PDU or protocol unit, of layer 2 of the OSI model contains the source and destination MAC address. The MAC address is the physical address of the network interface card or NIC. Now, this is a hex address that is a burned-in address attached to the physical Ethernet interface, which cannot be changed on a NIC. Each NIC has a hex address assigned by the manufacturer. Now, the address itself is a 6-byte address. The first 3 bytes of the address are unique to the manufacturer and are often referred to as the organizationally unique identifier, or OUI, portion of the address. Now, the last 3 bytes are unique to the NIC itself. This helps find the actual location of the devices. So there is also a cyclical redundancy check, or CRC, value that is used to help verify the frame is error-free. This is very important because the frame needs to be error-free in order for the payload to be relied upon. Now, when it comes to the transmission of Ethernet, there are often 2 options: half duplex and full duplex. Half duplex enabled means that the endpoint transmits the frame only after the endpoint waits for an idle period when no other endpoint is transmitting. This helps to avoid collisions. Carrier sense multiple access with collision detection, which is also known as CSMACD, is the type of environment that uses half duplex. The endpoint attempts to prevent the collision from happening so that it does not send out a frame. When using CSMACD, there are endpoint steps within the process. First, prepare the frame for transport on layer 2, and query if there is any traffic being transported over the link by anyone else. If there is, it will wait, and if not, it will start transmitting. Next, query if a collision has occurred. If a collision has not occurred, it ends the frame transmission and waits to transmit again. If a collision has occurred, the endpoint follows another procedure. The sending node monitors the transmission, so when it notes the collision, it'll send out a jam signal, which is a signal sent out to all possible ports in the hopes that it reaches the intended destination of the original traffic to signal. It warns that there is an error in the traffic. If the maximum amount of transmissions has been attempted, the connection is aborted. Now, a backoff timer is then started, which is calculated randomly based on the collisions that have occurred, and it will restart the transmission process. A good example of this process is a conversation with a group of people. When one person talks, hopefully the others wait around until that person is finished before talking. If 2 or more people start talking at the same time, then they pause for a random period of time in order to allow the other to finish talking and avoid chaos. The other option, which is significantly better, is full duplex. Endpoints can simultaneously transmit and receive data. Now, there's no need for collision detection with full duplex, as there is a guaranteed detected collision-free connection between 2 endpoints in a full duplex connection. So here's an analogy. Think of a bridge over a river as full duplex, because it's not possible for traffic to turn in and out or in front of it on either side street while you're driving. Now think of a street with many side streets as half duplex. And as you're traveling down that half duplex street, you have any chance that cars can pull out in front of you. Full duplex is double the bandwidth of half duplex, but both endpoints must have settings that match in order for full duplex to occur. Full duplex must be configured on both endpoints. Now let's take an overall look at the different types of Ethernet available. We have 10-base-2, 10-base-5, which is also called ThinNet and ThickNet, and the Ethernet standards that run over coax cable. Now, ThinNet has a maximum distance of 185 meters, and ThickNet has a maximum distance of 500 meters. Now, Ethernet-based standards that use twisted pair are 10-base-T, 100-base-T, and now 1000-base-T. 1000-base-T has speeds of up to 1000 megabits per second. 100-base-T goes up to 100 megabits per second, and 10-base-T goes up to 10 megabits per second. And finally, there is 100 base FX, 1000 base LX, and 1000 base SX, which are standards of Ethernet that run over fiber optic cabling. Now, in order to better understand Ethernet, it helps to understand broadcast and collision domains. A broadcast domain is a layer 2 logical separation of devices, which can be reached via a unicast or broadcast message. A collision domain is a division within a broadcast domain where frames from one device could collide with another. An Ethernet hub is a notorious device for being one giant collision and broadcast domain. All ports on the hub can hear messages from a sender, as it does not have the intelligence to know how to segment collision domains like a switch does. A switch learns where particular devices are maintaining a table of MAC addresses to switch ports and therefore sends data only to where it needs to go. Now, a switch port is its own collision domain. The switch still encompasses one giant broadcast domain, but the broadcasts are generally much lower in frequency because a switch will learn where to send traffic after a learning process takes place. Now, one of the most significant differences between a hub and a switch is content addressable memory, or CAM table. A CAM table is used in a switch to remember where particular MAC addresses are located on attached ports. Now, when a switch receives a frame for the first time, it does not know where to send it, so it floods to all ports except the one that it came from. Now, once it finds the port it is supposed to go to, it keeps the information in the CAM table for future reference for a specific amount of time. Now, the next time a port needs to send to that specific MAC address, it sends it to that port, unless the information is removed for being too old per se, without flooding the entire device.